Today for you, we're unpacking a transformative vision for 2030 and beyond, based on the comprehensive analysis from the Alpert research team. This isn't just about faster phones. It's about the emergence of 6G as a foundational, intelligence-native infrastructure that will underpin a fully immersive cyber-physical society. We'll offer a clear roadmap to understand how 6G differs from previous generations, why it's urgent, and how it truly redefines the intersection between technology, society, and global competitiveness.
This deep dive examines the limitations of 5G, identifies the key technological and societal drivers accelerating the shift towards 6G, and articulates the ambitious vision underlying this next-generation network. We'll outline its performance benchmarks, core enabling technologies, and the global standardization roadmap that positions 6G not merely as an incremental upgrade, but as a truly transformative leap beyond just connectivity. 5G still feels pretty new for a lot of people.
Fair.
Why the big push for 6G already? Can't we just, patch 5G? Is 6G really starting from scratch?
That's a really good question. And yeah, 5G was a leap. But the demands coming by 2030, both societal and industrial, they're just evolving so fast. Alpert's research highlights what they call 5G's intelligence gap. It just wasn't built with AI deeply embedded, which you need for truly smart autonomous systems. Plus, the energy consumption at massive scale. It's a real concern. Unsustainable, potentially.
And performance.
And the performance piece. The report calls out the silent killer. It's the unpredictable latency, the jitter. You need that deterministic sub-millisecond response time. 5G, as good as it is, doesn't guarantee that consistently. And let's not forget, those frustrating coverage dead zones still exist. So yes, 6G is in many ways more of a clean slate architecturally. It's designed to tackle these fundamental issues head-on, not just plaster over them.
Okay, that makes the why now much clearer. And the report also mentions this isn't just tech talk. It's framed as a geopolitical and economic imperative.
It really is. The stakes are huge. National security, keeping critical infrastructure running smoothly, leading innovation. It's all tied up in 6G leadership. Lagging behind isn't just about slower downloads. It means potentially falling behind in advanced manufacturing, securing your nation's core systems, the next wave of AI. It's a global race, no question.
So if 5G has these gaps, what's the big vision for 6G? The report uses this term, cyber-physical world. What does that actually look like?
It's a fascinating concept. Imagine everything physical having a smart digital twin, constantly synced up, learning, predicting, optimizing what happens in the real world. It's a move towards what they call intelligence-native architecture. AI isn't bolted on, it's woven into every single layer of the network. Self-optimizing, self-healing, even anticipating needs before they happen. It's less about just connecting devices and more about creating this aware, intelligent environment all around us.
That sounds powerful.
Yeah.
What kind of performance are we actually talking about? What are the targets?
The benchmarks are, frankly, staggering. Speed first, terabits per second, that's like 100 times faster than peak 5G.
100 times. Wow. Enabling what?
Things like real-time holographic chats, truly immersive XR that doesn't make you nauseous. Then there's latency. We're aiming for sub-millisecond, maybe even down to 100 microseconds for critical stuff. That unlocks the tactile internet remote control with physical feedback.
And reliability.
Yeah.
You mentioned safety-critical systems.
Yes, this is huge. 6 nines reliability, 99.9999% uptime. Plus, massive capacity increases, handling maybe 10 to 100 times more devices, even things moving super fast, over 500 kilometers per hour. And critically, targeting 100 times better energy efficiency per bit than 5G.
Okay, those numbers are wild. How on earth do we build that? What tech makes it possible?
It rests on several key innovations. First, using much higher frequencies terahertz or Terahertz communication. That's the 100 gigahertz to 10 terahertz range. It's like wireless fiber for those terabit speeds.
But don't those high frequencies have trouble like going through walls or even rain?
They do. That's a major challenge. Which brings us to the second piece. Reconfigurable Intelligent Surfaces, or RAIS. Think of them as smart mirrors for radio waves. They're programmable surfaces that can dynamically steer those Terahertz signals around obstacles, bounce them where they need to go, eliminating dead zones.
They leave with the AI part.
That's the third pillar, AI native networking. The network manages itself, adapts constantly. It uses things like federated intelligence, where AI models learn locally on devices or edge nodes without sending all your raw data back to a central cloud. That's better for privacy and cuts down network traffic massively, potentially up to 90% less backhaul needed.
And covering the whole globe, satellites.
Yep, that's non-terrestrial networks, NTNs. Integrating satellites, drones, high-altitude platforms seamlessly with ground networks, a true space-air-ground-sea fabric for communication everywhere. Oh, and one more, integrated sensing and communication, I say. The network signals don't just carry data, they also sense the environment. High-precision positioning, detecting objects, understanding gestures, all built in.
Okay, it's a complex picture. What's the timeline? When might we actually see 6G roll out?
Well, the standardization work is ongoing in 3GPP. Release 20, running from about now, 2025 to 2028, is crucial. That's where they'll nail down the use cases and technical requirements. Release 21, around 2029, 2030, should be the first official 6G spec, so initial commercial deployments. Probably starting around 2030, but widespread global rollout, the whole ecosystem maturing, that's likely more towards 2033 to 2035.
With all this sensing, data, and AI, the ethical side feels massive. The Alpert report seems to stress this.
Absolutely critical. They emphasize privacy by design. It has to be baked in from the start, not added later, especially if the network is gathering potentially real-time biodata. That means clear user consent, transparent policies, probably new legal frameworks too. Data sovereignty is a huge piece of this puzzle.
And sustainability. You mentioned the energy efficiency target.
Yes, that 100x improvement per bit is a core goal. And the AI managing the network, it could cut overall network power use. Beyond the network itself, the report suggests 6G could positively impact, I think it was, 79% of the UN's Sustainable Development Goals through smarter cities, better climate monitoring, digital inclusion. As we look toward 2030 and beyond, it becomes increasingly clear that 6G is not simply the next chapter in wireless evolution. It represents a foundational shift in how we connect, compute, and interact with the world around us. Rather than serving as a marginal upgrade to existing systems, 6G is envisioned as an intelligent and adaptive infrastructure layer for a fully cyber-physical society, where artificial intelligence, pervasive sensing, and real-time responsiveness are seamlessly embedded across all levels of our digital and physical environments. The Alpert research team's insights underscore that realizing this vision will require more than technological breakthroughs. It demands coordinated global action, significant investment, and the development of robust ethical, privacy, and governance frameworks to ensure that these advancements benefit humanity equitably and responsibly. If you're interested in a deeper understanding of this transformative shift, we invite you to explore the full analysis. A comprehensive and detailed review of the Alpert research team's presentation on the future of wireless communication is available at the following link.